Hi and welcome back. In this video, we'll understand data replication. So HDFS is designed to reliably store very large files across machines in a large cluster. It stores each file as a sequence of blocks. The blocks of a file are replicated for fault tolerance. The block size and replication factor are configurable per file. An application can specify the number of replicas of a file. The replication factor can be specified at file creation time and can be changed later. The name node makes all decisions regarding replication of blocks. It periodically receives a heartbeat and a block report from each of the data nodes in the cluster. The receipt of a heartbeat implies that the data node is functioning properly. A block report contains a list of all blocks on a data node. The placement of replicas is critical to HDFS reliability and performance. Optimizing replica placement distinguishes HDFS from most other distributed file systems. This is a feature that needs a lot of tuning and experience. Let's now see how data is placed across the Hadoop cluster, which is also known as rack awareness. The purpose of a rack aware replica placement policy is to improve data reliability, availability, and network bandwidth utilization. The current implementation for the replica placement policy is a first effort in this direction. Hadoop's default strategy is to place the first replica on the same node as the client. For clients running outside the cluster, a node is chosen at random, although the system tries not to pick a node that's too full or too busy. The second replica is placed on a different rack from the first, and this is chosen at random. The third replica is placed on the same rack as the second, but on a different node chosen at random. Further replicas are placed on random nodes in the cluster, although the system tries to avoid placing too many replicas on the same rack. Once the replica locations have been chosen, a pipeline is built, taking network topology into account. For a replication factor of 3, the pipeline looks at what is on your screens. Overall, this strategy gives a good balance among reliability, write bandwidth, read performance, and block distribution across the cluster. Alright, so that's it for this video. I'll see you in the next one. Thank you.